Hi there, this video today we're going to be talking about volume. So volume is the amount of space inside a 3D object. Or if you threw this object into a bath or something like this, how much water would be displaced, the volume of water displaced. So it's how much stuff is on the inside. We've got some simple formulas here for a prism. The idea behind volume is that we've got the area of the top part of the prism, or you could say the cross-sectional area, so this part here, and then we just times it by how high it is. So if you think about a block like this that's maybe 2 by 2, and we know the area there is 4, and then we build another block on top of it. Excuse my terrible drawing. There we go. So now we've got a block that is 2 high, so the area would now be 8, etc., etc. Okay, and we build it up. So the area is just the the volume is just the cross-sectional area times by how high it is. And that formula is the exact same for a cylinder. We just work out the cross-sectional area, which is pi r squared, the area of a circle, times it by the height of the cylinder. So pi r squared h is the formula for the volume of a cylinder. So for these two examples here, we're going to apply that idea. For the first one, for part A, the volume is just the cross-sectional area, which is 8.2 times 17. That's the area of that base there. And then we just times that by 4.3 to get the volume of the whole shape. And this is easy because it's in centimeters, so we don't have to worry about the units in this case here. So let's get the trusty calculator out. 4.3, and we get 599.42. So 599.42, and the units here is centimeters cubed now. Centimeters cubed. So if you wanted to make a conversion now, remember that 1 litre is 1,000 centimeters cubed. Okay, so dividing this, it's around about 0.59942. So it's about 0.6 of a litre of fluid that you would be able to fit in that box. Okay, part B. Again, I'm just going to work out the area of this cross-section part here, and then I'm going to multiply it by the length here. So it's a half base times height. That is the area of that triangular face there, and then we multiply it by 3.4. So getting the calculator out, 0.5 times 1.9 times 2.6 times 3.4 gives us 8.398. And these were all in meters, so this is meters cubed. When we do another conversion here, we know that 1 meter cubed is 1,000 litres. So if we wanted to convert this to litres, we just multiply this by 1,000. Okay, 8,398 litres would fit in that triangular prism shape. Okay, these two are really easy. The volume for the first one is the cross-sectional area times by the height. So 38 times 6, which you could do 30 times 6 and then 8 times 6. So 30 times 6 is 180, 180 and 8 times 6 is 48. So 228, or of course you can get your calculator out. In this case here, we've got centimeters cubed. Conversion here, milliliters, centimeters cubed, and milliliters are the same thing. So this is 228 milliliters. Okay, just close to a quarter of a litre, if you like. Part B is a cylinder, so the volume is going to be pi r squared times by the height. In this case, just watch out for the units again. All of these are nice, they're all in millimeters and centimeters. Just be careful for these if they have 1 in millimeters and 1 in centimeters, so you're using the same unit. Okay, so it's 500 pi, or you can give your answer 1570.8 millimeters cubed. Now let's say we wanted to write that in centimeters cubed or milliliters, because millimeters cubed doesn't mean a lot. So King Henry died by drinking chocolate milk. We're here in millimeters. if I want to go to centimeters, the decimal place has to go back once. Because we're going from millimeters cubed to centimeters cubed, that decimal place needs to go back 3 times. Once, 3 times. We need to take this decimal place back 3 places to get it to centimeters cubed. So 1, 2, 3 places. 1.5708 centimeters cubed. This is a pretty tiny shape, okay? It's only about 1.5 milliliters that will fit in here. So 10 millimeters, that's only 1 centimeter across, and 5 millimeters is only half a centimeter. So this is a very small little disc here, okay? So 1.5708 milliliters. All right, these last two are a little tiny bit more challenging for part A. Hopefully you can see for the first one that it's a cylinder, but it's not a whole cylinder. So what fraction of the cylinder have we got? Well, if that angle there is 120 degrees, that means the fraction of the cylinder we do have is 240 degrees. So 240 out of 360. That's the fraction of the whole cylinder that we have there, which is actually 2/3. So we've got 2/3 of the whole cylinder. And we know the formula for the volume of the cylinder is pi r squared times the height. Now, again, are we going to do this in millimeters? Are we going to do this in centimeters? If we were going to do it in millimeters, I would convert the centimeters to millimeters and call that 17 centimeters is 170 millimeters. That would give us our answer in millimeters cubed. Or, that's probably easier, isn't it, if we do in centimeters. So if I go pi 8 millimeters, okay, 8 millimeters to get to centimeters, move the decimal place back 1. So that's 0.8 times 17. Okay, so 240 divided by 360 times pi times 0.8 squared times 17 gives us 22.8 centimeters cubed for the first one. All right, second one here, we've got, obviously, or hopefully you can see, we've got the triangular prism, and then we've taken out this cylinder. So when we work out the volume, we're going to go 1/2 times the base times the height, times by how long it is, so that we're going to get the volume of that triangular prism, and then we're going to take off this area of the cylinder. Now, if we want to get the height, we need this part right here. So let's do that first. In order to get that, we're going to have to use Pythagoras' theorem. This is 4 centimeters along here. This is 2.4. So if I call that whole length x, the length of that side there, we've got x squared plus 2.4 squared is 4 squared. So if I subtract 2.4 squared from both sides, like that, that gives me what x squared is. So I'll do that on my calculator. 4 squared minus 2.4 squared, that gives me 10.24. And then x is the square root of that answer, which is 3.2 centimeters. So now I know what the length of that whole side is there. So let's work out the volume. Is going to be 1/2 times the base, 2.4, times the height, which is 3.2, times by 3.7. So that will give us the volume of that triangular prism, and then we're going to subtract off the volume of the cylinder, okay, which we know is pi. Now remember, this is all centimeters, so we're going to stay in centimeters here. 9 millimeters is 0.9 of a centimeter, and that is the diameter. Okay, so the actual radius is 1/2 of that, 4.5 millimeters, or 0.45 centimeters. So pi r squared times the height, and in this case the height of the cylinder is just the length of the cylinder, which is the same, which is just 3.7. So let me get my calculator out, and I get 11.85 centimeters cubed. There we go.